So we're looking at Boolean expressions and logical operators. We have multiple Boolean expressions. I'm going to start with our ones that we're familiar with. We're going to put in two variables. We're going to have age, and we're going to set the initial age equal to 12. And we're going to set height equal to 54, and that would be 54 inches. And so we could do that. We want to do this actually as a numeric comparison, so we won't put the inches next to it. So we have age of 12 and height of 54. And what we're going to be evaluating is the theoretical idea is, can somebody ride a particular ride at the amusement park? So we have different comparisons we can check. We can check if age greater than 12 we can check if age less than 12, if age equal to 12, if age not equal to 12, or we could do if age greater than or equal to, that's what that represents, 12, if age less than or equal to 12. And these are all valid options. And let's take a look at how they'd evaluate. So if age is equal to 12, it's not greater than 12. So this would be false. Age is not less than 12. This would be false. It is equal, but that needs a second equal sign for a comparison. So this would be true. It's equal to 12, so not equal would be false. Greater than or equal would be true. Less than or equal would be true. So those are the way that those things would evaluate. And we're going to actually do some programming code so we can evaluate using these expressions, combined expressions using using or, using and. And in Python, we actually use the and or terms. And we can also use not. So we can do a basic statement, if age greater than or equal to 12 and height greater than or equal to 54, and then if that evaluates true, we'd do whatever comes next. So right now, this would evaluate to true. If we make it greater than or equal to 10, it would still be true. If we make it greater than or equal to 16, the whole statement would evaluate to false. If you have the word and, that means that both sides of the equation have to be true for the entire equation to evaluate to true. If you do an or statement, it would still be okay. This would evaluate to true because even though age is not greater than or equal to 16, height is greater than or equal to 54. So if either side of an or equation is true, then the entire one is true. You can also use the not statement like these. Instead of using the not equals, we can use an expression of not. So instead of age, we will have child as a variable, and we'll set it equal to true. So if not child would evaluate to true here, because So if not child, that would be the opposite, would be an adult. So child is true, so this would evaluate to false because child is true. If we set that to just be if child, so that would imply that it's true, we can do things that way. So when you're using a Boolean, which is a true or false option, and you use a capital T or capital F with those, you can just use if child, if not child, instead of saying if child equals true. It's a shorthand for the same evaluation.